Hello friends, welcome back to Scientific Blunders, where you learn the don'ts first. So this is one of those rare videos that went beyond my planned time, and so I'm going to have to extend this a little bit, but I'm going to try to keep this video short. Um, so this is where we actually left off, right? Let me quickly review what we did because it's quite a lot of details and a lot of equations that we wrote, many different cases. So I just want to quickly review it and then we can solve this problem without taking too much of your time. So a ball of mass m suspended by a massless string of length L was released with a certain speed v, and we were told that v was sufficient to make the bob go all the way to the top, right? And we want to find the angle at which the speed of the bob is v by 2, essentially half of that of a, right? So we started off with the equation for centripetal motion, the equation for circular motion using centripetal force, and then we applied the conservation of energy. We found a speed of square root of 4gl, but we were not sure whether that was correct because we also got a tension of minus mg, which doesn't make sense. A tension of 0 is okay because that indicates that the string is slack, but a tension of negative tension doesn't make sense. So because we were confused, we actually tried to understand what happens when the bob is released with a speed of square root of 4gl, right? So we first assumed that circular motion may not be true all the way to the top. So we just tried to find the point up to which circular motion is executed, right? So by assuming the tension to be 0 and solving these two equations, we found, what did we find? We found the angle at which the tension becomes 0, which is cos inverse of minus 2 by 3, which is between pi by 2 and pi, so somewhere here. And we also found the speed of the bob when the tension becomes 0. So it's square root of 2gl by 3. But this gives us an important insight because for this particular speed of square root of 4gl, this tells us that the bob goes all the way to this point, right? Its speed is not 0 yet, right? It has a speed of square root of 2gl by 3, but the tension becomes 0. That means it no longer can execute circular motion. It's basically under free fall. So it's like a projectile released at an angle. And it's basically under free fall because there's nothing that's pulling it to the center. And what does the projectile do? Well, it executes parabolic motion, right? From our kinematics and laws of motion that we learned earlier, it's going to execute parabolic motion. So it's going to be something like this. So it's going to lie below the circle, and when it reaches a point on the periphery of the circle, the string is going to become taut again, and that's going to produce an impulsive force, and at that point the motion of the bob is going to be more complicated than we can analyze. So this was a big learning, right? Because earlier when we actually did the blunder, we actually assumed that the bob would go all the way to the top, and we applied equation 1 for at point B, but we were wrong. Why were we wrong? Because the bob does not even reach point B. The string starts to slacken off over here itself, which means that what we did earlier was actually wrong because equation 1 is only valid between point A and point O. It's not valid all the way to point B, which is at the top. So this is a big learning, right? So we have to remember we still haven't solved the problem yet. So the problem is to find the speed at which the bob is half of that of point A, and we need to find the speed at point A first of all, because square root of 4gl is wrong because it's not even going to make it all the way to the top. So how do we find the speed that is needed to make it reach point B? So that is what we're going to work on, and then we want to plot these different speeds for which we have different cases at the very end, right? So let me actually, I don't want us to be confused by these different cases now. So we can do that at the very end. But now let's work on the actual problem now that we have identified our mistake, right? So let me quickly redraw the problem. So it always takes a little bit of time to redraw this a few times, but I think it's nice to have a big and clean diagram always. So we have a circle. circular motion which the bob is going to execute. Right, so there's a bob that's released from the bottom with speed v, and we know that it goes all the way to the top. So the bottom is point, what is the bottom? The bottom is point A and the top is point B, and we have been told that the bob goes all the way to the top. Right, so again, what I like to do, as I mentioned in the previous video, for these problems I always like to consider an intermediate angle theta, or an intermediate position when it's at an angle theta with respect to the vertical. And remember, I wrote down two equations, so I'm going to use the same equations one more time. So let's copy paste equation 1 and 2. Equation 1 is centripetal force, equation 2 is conservation of energy. And this time I am not going to make a blunder, because I've realized that for certain speeds the bob, the string will slacken off even before the bob reaches the top, and so then the circle will not be completed. Instead it will follow a parabolic path, and then the motion becomes very complicated, right? So what I want to know is, for what speed v will the bob actually reach the top? Alright, so how do we find that? Well, the first thing we did, the first blunder we did, was to say for the bob to reach the top, the speed at the top must be 0, because it barely reaches the top. But then we realized that's not true, because the string can slacken off like it did earlier. Remember, here the string slackened off, or the tension in the string became 0, even though the bob had a non-zero speed. So the condition to reach the top is not for it to barely reach the top with 0 speed, but for the string to slacken off at this point. Because if the string slackens off at point B, at that point it has already reached the top. And then as it, it's like we saw here, even when it slackens off, its speed is going to be non-zero. And so that speed is going to give it, enable it to continue the circle. And once it moves over to the other side, it will automatically complete the circle. So if that doesn't make sense, let's actually try to enforce what I just said using equations. Okay, what I'm saying is that for the bob to reach all the way to B from A, the tension at point B must be 0. Tension must be 0 at point B, and that will ensure, as we saw earlier, even when the tension is 0, the bob is going to have a non-zero speed, and that speed is going to help it complete the rest of the circle, right? So let's see what we get when tension equals 0 at point B. And what is true at point B? Well, theta would equal pi radians, right? So 0 minus mg cos pi, so that's mg, must equal mvo squared by L. Okay, so VO would be square root of GL. And what is VO? VO is the speed at any point O, and in this case point O and point B are the same. So the bob is at the very top. So the bob is at the, oops, okay, the bob is at the top. To have a steadier hand, yeah, the bob is at the top, and we have just found out that at this point the tension is 0, so it's almost as if the string doesn't exist, and the bob still has a speed of square root of GL, which is VO, which is also the same as VB, speed at point B. B and O are the same for this case. Alright, so now that we've found VO, we can actually find B, because theta is known, VO is known, everything else is known, right? So in equation 2, M will cancel, right? Theta is pi, so cos pi is minus 1. So 1 minus minus 1 is 2. And yeah, so bringing the 2 over to the other side, we get minus 4GL equals V naught squared, which is GL, minus V squared. So V is actually the square root of 5GL, right? So this is interesting, right? So for a speed of square root of 5gl, we have found that the bob will reach the top. At the top the tension is going to be 0, so it's almost like for a brief instant, for a split second, the bob is going to be under a free fall here. But remember, even though it's under free fall, it already has a speed that's making it move to the left, right? So it's not just going to drop down all of a sudden, but because of this speed, it's going to complete the rest of the circle. All right. So this, my friends, is the right speed to be provided. So just to remind ourselves what the question was, the horizontal velocity v at position A, to make it reach point B, was not square root of 4gl. So we realized that this was wrong, but it's actually the square root of 5gl. Right? This is the speed that's necessary to make it reach point B, barely enough to make it reach point B. For any speed higher than this, it's going to complete the circle, and the tension at the top is not going to be 0, it's going to be greater than 0. But this is the minimum speed required to make the bob reach all the way to the top. And this is actually, there are several problems of this kind that you'll encounter, and so this is a result worth remembering. What is the minimum speed required for the bob to reach the top? Square root of 5gl. It's actually worth remembering, and you don't have to memorize it blindly because this can be derived using just 2 equations. So now the question was, what is the angle theta at which the speed becomes half of that of speed A, right? So let me scroll down a little bit more. Oops, random lines again. Okay, so let me scroll down a little bit more. So we know that the speed at a point O, let's say, at which the speed becomes v by 2. So VO must be v over 2, and v is the minimum speed that we provide. So v is v min. So this is nothing but the square root of 5gl over 2. And now we can substitute these two in equation 2 to solve for theta. Alright, so what do we get? So minus gl times 1 minus cos theta. Remember, the m cancels on both sides. M cancels. That must equal half of v naught squared, which is 5gl by 4 minus v squared. Right? V is v min. Right? We provide the minimum speed required at the bottom for the bob to complete the circle. So that's going to be 5gl. Wonder why these random lines start showing up. Sorry about that. So this is 5gl, and the gls will cancel. Okay, we just have to solve for theta at this point. So let me scroll down some more. So what do we get? Minus 1 plus cos theta equals 5 by 2. Right, I'm taking the 5 out of the brackets. So 5 by 2 times 1 by 4 minus 1. So that's minus 3 by 4. Right? And rearranging, so cos theta equals 1 minus 15 over 8. And so theta equals cos inverse of minus 7 over 8. And we are done. We are almost done. All that remains is, well, I'm going to box this, but that's not all that remains. Oops. All that remains is we were not actually given the actual value of theta, but we needed to find the range in which theta lies, right? So we have found out that theta is cos inverse of minus 7 over 8. That's the angle at which the speed of the bob is half of that away. So is that pi by 4? No, because cos pi by 4 is 1 over root 2. Is that between pi by 4 and pi by 2? So is it in this quarter circle? No, right? It's cos inverse of a negative number will have to lie between pi by 2 and pi. So this is not true. And the next question is it between 90 and 135 or 135 and 180, right? So we actually need to do a little bit of simple mathematics or simple analysis. So on this line, I'm going to plot theta, and on this line, I'm going to plot cos theta. Okay. So when theta is pi by 2, cos pi by 2 is 0. When theta is pi, cos pi is minus 1. When theta is 3 pi by 4, what's cos 3 pi by 4? Well, it's minus 1 over root 2. And now we need to understand where minus 7 over 8 lies, right? So minus 1, so at this point the problem is basically over, but in JEE it's not over until you actually shade it. So let me also actually find out where minus 1 over root 2 lies. So minus 1 over root 2, root 2 is 1.414, which is very close to 1.5. So that's roughly minus 2 over 3. Okay. So minus 0.67. So minus 1 over root 2 is minus 0.67. And what about minus 7 over 8? Well, minus 7 over 8 is going to be, what's 7 over 8? I feel really young when I do all of these things again. So it's 0.875, right? 7 over 8. So minus 0.875 is going to lie somewhere here. Okay, so that means theta, just as you observe the pattern here, is also going to lie somewhere here. So theta lies between 3 pi by 4 and pi. So that brings us to the end of a long 2-series video. And if I had to summarize all of this, I would say I would like to do it in a beautiful line diagram. And I don't think anyone else has done this, but I like to think about it this way, because there are different cases, right, when you look at vertical circular motion. And we need to understand what kind of circular motion is executed for these different cases. What we have found out today is that the minimum speed required to complete the circle is square root of 5gl. So for any speed greater than square root of 5gl, this is the axis where I'm representing the initial speed at the bottom. So for any speed greater than square root of 5gl, it is going to complete the vertical, it is going to complete the vertical circle. So the bob is going to start at the bottom, go all the way to the top, and then come back for any speed greater than or equal to square root of 5gl. For extremely low speeds, it is going to execute simple harmonic motion. Extremely low speeds, amplitudes like really small, right? So where it's just oscillating, just here, like an angle of at an amplitude of 5 degrees or something. So that's going to be simple harmonic motion. But we also found, remember we found that for a speed of square root of 4gl, the bob actually doesn't make it all the way to the top, right? It goes and then the string slackens and then it follows a parabolic motion, right? So that means there exists a certain range of speeds where it the vertical circle isn't completed, right? What I'm going to provide the answer to you, but I'm going to leave that as an exercise, is that for a speed of square root of 2gl, right, and we didn't derive this in this video, I'm going to leave that to you as an exercise. For any speed between 0 and the square root of 2gl, the bob, for a speed of square root of 2gl, the bob will go all the way to a theta of pi by 2, at which point the string will slacken, and then the bob will start to fall down, and it's going to continue to execute circular motion, right? And we haven't derived this, but I want to leave that for you as an exercise. For a speed of square root of 2gl, anywhere between speed of square root of 2gl it's going to partially, or let me call that partial circular. I always use these very unconventional terminologies, but I hope you get the idea. Partial circular motion. And finally, for any speed in between square root of 2gl and 5gl, it is going to execute these weird lines just keep coming up from somewhere. So any speed between square root of 2gl and 5gl. Example, well, what we did a mistake with, square root of 4gl. The bob is going to start off executing circular motion, then slacken off, and then execute free fall. So that's going to be a projectile, so that's parabolic motion. So it's going to be partial circle and then a parabola, which is basically what you get when you release a projectile at an angle. So I know this was a very long 40-minute two-part series, but the bottom line is vertical circular motion is complicated, right? Depending on the speed at which the bob is released at the bottom, the bob may or may not get all the way to the top. For extremely low speeds, it executes SHM at an amplitude of, let's say, 2 degrees or up to 5 degrees. For speeds between 0 and square root of 2gl, it is going to go all the way to, it may go all the way up to an angle of pi by 2 and then keep executing that. It's not going to slacken off anywhere. For a speed between square root of 2gl and square root of 5gl, it's partially going to complete the circle, but then the string is going to slacken off. And then it's going to be in free fall, so it's going to be like a projectile and execute parabolic motion. And for any speed greater than square root of 5gl, it is going to complete the entire circle. So when I first did this problem, the problem doesn't require you to do all of these things, but this is what I did, and I found that this exercise, gave me a much deeper understanding of vertical circular motion. So I hope you found this video useful, and this was probably the longest video that I've taken, but sometimes it takes a lot of time to get a deeper understanding. And so I hope you found this useful, and I will see you in the next video. Bye.